So, hello guys, kamusta? So, I've been asked to give a talk about mathematics, so that's why I'm here. So, sorry na lang na I can't be there in person, pero this is the next best thing. We're going to have a pre-recorded talk na lang, where hopefully I give some of my experience and knowledge from joining math competitions over the years, and hopefully I can help you solve math too. So, actually 5 years na, kaya baka hindi na ako kilala. So, I am Kyle Dulay, PSHS alumnus, graduated 2018. I was a PMO national finalist from grade 7 to 12, part of the IMO team in grade 8 to 12. So, I have some experience in solving Olympiad problems. So, for today, we're going to look at the 25th PMO area stage problem. So just an overview of what I'm planning to do today. So the intended audience of this talk would be someone getting into Olympiad mathematics pero hindi pa umabot sa national stage. So if I recall correctly, that would be someone who's used to solving short answer type problems pero is intimidated pa by proving problems. So my objective for today is to show the process of solving problems. So what do I mean by that? So I don't necessarily mean how to write down the proof, how to present a logically consistent solution na that works for the problem. I'm more thinking of how do you get to that proof? How do you get all the building blocks to make that logically consistent proof, to make that argument. So as such, I'm going to focus on a few problems lang. Not every problem, although I'm going to add some hints at the end of the slides, just in case you want to try the other problems from this year. And disclaimer, the PMO this year is harder than usual, so feel free to pause at any time. So not just when I'm showing the problems, pero while I'm discussing the solutions rin, maybe you have an idea on how to proceed, so feel free to pause at that point rin and continue by yourself. So with that, let's move on to an outline first. So the first part of this talk would be on problem solving itself. So that would be more of the prove this is true, or show with proof that the sum is this, or find with proof that the answer is this. So the parts with proving. So the key difference between that and short answer would be short answer you can survive by just guessing and being lucky, or just looking at something, thinking it's true, and then just writing it down. So problem solving, it has to be a little bit more rigorous, but at the same time, sa problem solving, there's still a little bit of aspects ng guesswork, which is what we're going to show later. So for problem solving, some tips on how you can do that is first, you play around with the problem, you make observations on what seems to be true, what seems to be what you can prove. You can also try small cases. For example, if the problem is 2023, you can try it for n equals 2, n equals 3 instead. So next is to change your perspective. So sometimes you're focused on a particular way of looking at the problem na you miss out on another way of looking at it that makes it more obvious how to proceed. Because sometimes parang pinipilit mo yung approach mo. It could work pero mahirap. Pero if you just tweak your perspective, like different yung variable na titingnan mo, different yung object, baka mas madali siya. So I'll give concrete examples later if this is too abstract. Next, of course, is to prove or disprove your guesses. Not all of your guesses are right, so you have to be open to throwing away something if it proves to be wrong. And then we have special exceptions for geometry, because geometry is very different from the other questions, that it needs its own tip section. Then finally, the role of experience in problem solving. So there we go. So let's move on to our first problem. So this is problem 19. So let P be a permutation of integers from 1 to 6 for any permutation P, we count how many integers there are which have nothing bigger on its left. We let f of P be the number of these integers for the permutation P. For example, f of 6, 1, 2, 3, 4, 5 is equal to 1 because only 6 has nothing bigger to its left, which is bigger. On the other hand, f of 1, 3, 5, 4, 6, 2 is 4 because only 1, 3, 5, and 6 satisfy the condition. Let S be the sum of fp over all the 6 factorial different permutations. Find the sum of the digits of S. So, the first step in a problem is to play around with it first. So we don't necessarily try to compute S diretio because the condition of f of p, it seems too chaotic, diba? Parang different permutation, different yung value niya. Parang it seems na there's no obvious way to count how many permutations there are na f is equal to 1, how many permutations f is equal to 2. Hindi siya obvious. So that's why we're going to play around with the problem first to see if we can get some properties that will help us count the sum later. So first, a good way to play around with the problem is to try small cases first. So permutation of 6 integers siya. So what if we make a permutation of 1, 2, or 3 integers first? Would that make it easier? So as is shown on the slides, for a permutation of 1 integer, the sum is 1. Permutation of 2 integers, the sum is 3. 2 plus 1 is 3. Permutation of 3 integers, we have 3 plus 2 plus 2 plus 2 plus 1 plus 1, which is 11. So our answers for the first 3 lengths would be 1, 3, and 11. So do we see a pattern in this? So I don't see a pattern. So that's why we're going to change our approach, because trying this was not necessarily a bad thing, because sometimes in other problems this does work, like trying smaller lengths of permutation. Sometimes it does work, sometimes it gives a pattern. In this case, it doesn't give a pattern, so let's change our perspective. Let's look at the problem differently. So how else can we try small cases if not for shrinking the permutation? So instead of shrinking the permutation, what if we shrink the conditions? Because f of p is counting how many digits satisfy the condition. So instead of counting how many digits there are in total, what if we just focus on it 1 digit at a time? So how many permutations have the first element with nothing bigger on its left, second element with nothing bigger on its left, and so forth. So obviously, if we add nothing bigger on its left for the first element, second element, third element, up to the 6th element, you get the original f of p. So we broke down the sum in a different way. So okay, so condition 1, how many permutations have the first element with nothing bigger on its left? So obviously 6 factorial kasi there's nothing on its left, so always totoo siya. So how many permutations have the second element have nothing bigger on its left? Medyo hindi obvious, so iisa-isahin natin yung second element. So second element ay 1, so imposible kasi palaging mas malaki yung 2 to 6. Second element is 2, so pwede lang siya kung 1 yun nasa kaliwa. Tapos yung natitirang 4 elements, kahit ano na. Second element is 3, so pwedeng 1 and 2 yung kaliwa, and so forth. So if we add this up, we get 360 permutations such that the second element has nothing bigger on its left. 720 tapos 360, parang may pattern, diba? Parang nangalahati. Pero di pa tayo masyadong sigurado or what the pattern exactly is, so let's move to the third element. So I'm not gonna list it down here, pero you can do it yourself. Pero the number of permutations where the third element has nothing bigger on its left is 240. So you can pause if you want to convince yourself that that's true, or if you want to count it by yourself. So 720, 360, 240, parang obvious na may pattern. Parang yung una, 720 over 1, tapos 720 over 2, tapos 720 over 3. So, yung magandang guess is yung kung fourth element ba magiging 720 over 4, fifth element ba 720 over 5. So, technically, you can also try listing it na, pero that would be a bit hard kasi medyo marami ka nang i-list down at that point. So instead, let's try to prove yung guess natin. Kasi kung taming guess natin, mas madali nang ibilang yung fourth element, fifth element, sixth element. So, feel free to take your time to try to prove this claim. And we show that there are 6 factorial over k permutations where its kth element has nothing bigger in its left. So, okay, let's proceed. So this is the formal proof of this assertion. Consider an arbitrary permutation A, B, C, D, E, F and cyclically rotate its first k elements. So here's an example. 1, 5, 3, 4, 2, 6. The first 3 elements are 1, 5, 3. So i-equatin mo, magiging 3, 1, 5, 5, 1, 3. So, sa 1, 5, 3, obviously maximum yung 5. So, kung hindi 5 yung magiging third element, kunyari 1 or 3, nasa kaliwa si 5. So, hindi masasatisfy ng third element yung condition. Pero kung yung maximum, si 5, nasa third position siya, masasatisfy yung condition. So, mapapansin natin na we have a set of k permutations. Only one of them satisfies the condition. So, that's why 1 over k ng overall number of permutations natin satisfy the condition. So, we can now return to the original problem. So that's basically finding the sum of f of p over all permutations p. So we have simplified that to just 720 over 1 plus 720 over 2, etc. Okay. So, next problem. Oh nga pala, I'm not going to show the complete solution to every problem. I'm just going to give just enough na kaya nang isolve hopefully ng madali at that point. So next problem, algebra. For part 2, number 1. For a set of real numbers a, let a minus a be the set of distinct pairwise differences of a. So that is a minus a, well, defined there. So, if the cardinality of a minus a is 25, find the sum of all possible values of a. So, if you're not familiar with set differences, feel free to take some time to analyze what that means. So, basically, the set a minus a is you take 2 elements from a, pwedeng parehas na element, pero just take 2 elements from a, take their difference, tapos ipasok mo siya sa a minus a. So, ulit-ulitin mo yun until na wala ka namang pasok sa a minus a. So, try it out. Try it with some sets. And then, once you're familiarized with it, we can proceed with the video. Just a reminder lang, kasi part 2 siya ng areas, Part 2 siya ng areas. Kailangan mo actually ng proof when you write this down. So, hindi lang basta-basta na hulaan mo yung cardinality of A. Kailangan may justification ka na pwede yung cardinality of A na yan. So, for example, sabihin, i-claim mo, pwede yung cardinality of A 15. Hindi. Kailangan mo pang magbigay ng set with 15 elements such that A minus A has cardinality 25. Okay. So, yung first step natin kanina is to try small cases. So, what does a small case mean? What does a small case mean for this problem? If we try making 25 smaller, parang hindi siya nakakatulong, di ba? Kasi differences medyo malikot yan. Kasi for example, you have set A, 2, 3, 4, 5. parang paulit-ulit lalabas si 1. So 5 minus 4. So may 1 ka. 4 minus 3, may 1 ka. So parang malikot siya. Parang hindi mo pa rin mahirap makakuha ng observations from just knowing the size of A minus A. So instead, when we say try small cases, let's try small sets of A. Small sets A. Kasi, if we know the number of elements in A, then we can make our own sets with that number of elements, and then we can calculate A minus A by ourselves. So, mas madaling maglaro ng alam nating size ng sets na A. So, that's why we're going to do that. So, let's start with if A is a singleton, then obviously A is a linear difference, which is 0. If A has two elements, for example A and B, then cardinality of A minus A is 3, namely A minus B, 0, B minus A. So kung size 3, medyo hindi na siya obvious, so let's try making examples. Let's try about a few sets. So just in case for na hindi kayo sigurado on your understanding of A minus A, here are a few examples. So 0, 1, 2. So A minus A, that would be 2 minus 2, 2 minus 1, 2 minus 0, 1 minus 2, 1 minus 1, 1 minus 0, and so forth. So yung A minus A dyan for 0, 1, 2 would be negative 2, negative 1, 0, 1, 2. So notice na once lang yung nag-appear yung difference kahit na multiple times siyang lumabas as a difference because A minus A is still a set. So kahit ilang times siyang difference, once lang siya sa set. So I've put more examples of possible A's. So I think these are reasonable guesses for if you're playing with the problem, hindi ka sure kung ano yung size ng A minus A. Feel free to pause to verify na tama yung nakasulat dyan. And yes, it seems that for A of size 3, A minus A seems to be of size 5 or size 7 lang. You can try more sets if you're not convinced. Pero yes, 5 and 7 lang ata yung possible. For A equals 4, medyo may combinatorial explosion na tayo. So 0, 1, 2, 3, medyo it seems easy to check, diba? Kaya let's try it out. We get A minus A is negative 3, negative 2, negative 1, up to 3. Let's try another set A, 1, 2, 4, 8. You get this set. I didn't put other examples na because it's going to clutter up the slide. And you can try it by yourself. Feel free to try it by yourself. Try thinking of different sets A na size 4. Gaano kalaking A minus A nila? So is it bigger? Is it smaller than some of the sets here? So just so you can get a feel of the problem. So let's look back at what we have so far. So yung examples natin for 3 and 4. Let's look at what properties the set A minus A has. So parang una, kung may negative, may positive, diba? Which makes sense kasi kung masusulat mo yung differences A minus B, pwedeng B minus A. Tapos sunod, when we were calculating A minus A, palaging lumalabas si 0, diba? Paulit-ulit. Lumalabas si 0. So actually, we can write down some observations now from this point on. So, first one, I've just mentioned it. Yung second one, well, it's just a generalization ng previous observations na kung 0, 1, 2, up to a k minus 1 for example, then alam natin A minus A, malinis siya. Kasi yung buong continuum from negative k plus 1 up to k minus 1, lahat sila pwedeng represent as differences. Medyo obvious naman ata. Tapos yung third one, I mentioned it before. So, nakuha natin na yung A minus A has at least, we have an A minus A that has 2 times cardinality of A minus 1 elements. Yung next question is, yun ba yung pinakamaliit? So, can we possibly find an a minus a na mas maliit, than the a minus a given here? It turns out, hindi natin kayang gawin yan because you can prove that that is actually the minimum. 2 times cardinality of a minus 1. So, I'll leave it as an exercise to the reader. This should be a fairly straightforward problem. So, if you need a hint, try writing down the elements of a in ascending order, and then try finding 2 times cardinality of a minus 1 elements, differences, 2 times cardinality of a minus 1 differences from those cardinality of a elements. So, increasing order siya, so alam mo yung susubukan mo, diba? Parang biggest minus smallest, sobrang laki nun. What if you try biggest minus second biggest? Parang, tapos biggest minus third biggest. Parang, paglaraan mo lang until you find these number of differences. Okay, so back to the original problem. So, may intuition na tayo sa a minus a. May upper bound tayo. So, may lower bound tayo. So, if you solve for the possible values of the cardinality of a, you get it's between 6 and 13. So, nga pala, notice that importante actually yung hindi lang natin sabing a squared, sinabi natin a squared minus a plus 1. Kasi, kung a squared lang, masasakop natin si 5, pero it turns out hindi possible si 5. Kaya importante na we kept that minus a para ma-exclude natin yung possibility na yan. So, yung for the case na cardinality of a is 13, may explicit example na tayo kanina. Yun yung 0, 1, 2, etc. Pero, yung cardinality of a is 6, wala tayong explicit example. Parang, medyo hinulaan lang natin na a squared kasi yung differences, pero may mga zeros, tanggalan natin. Medyo alanganin pa. Baka, hindi natin alam, baka meron pang ibang repeated na numbers. Baka hindi actually abot si 6 kasi maraming differences yung paulit-ulit na magdidip below 24 yung yung size ni a minus a. So, hindi pa tayo sigurado technically. So, that's actually a good exercise rin. Try to find set a of size 6 that meets a minus a equals 25, has size 25. Para lang masigurado tayo na totoong bound yung 6 na hindi siya 7. So, once you found an example for a equals 6, next comes a equals 7, diba? Now, we're going to try to find a set of size 7 na a minus a has size 25. And then, do it for size a equals 8, size a equals 9. Parang medyo kakapagod yun, di ba? Kasi a equals 6 pa lang. Kung sinubukan nyo talaga na matatagalan kayo sa a equals 6. Kasi parang patalon-talon yung differences eh. Parang kailangan siguraduhin mong hindi marami yung tutugmang differences. Medyo mahirap siya. So instead of thinking of 8 different examples, parang papahirapan natin sarili natin, pwede bang konti natin yung examples na kailangan natin hanapin? Kasi sa contest time, 3 hours lang yung area. So, mauubos yung oras mo sa 8 different examples. Of course, recording lang to, so you can spend as much time as you want, and you should spend as much time as you want solving these problems. Pero, writing down your proof is also another thing na you have to consider. So, it turns out, narangan yung text. So, we're inspired to find a way to just use 1 or 2 examples and then build the rest na. So that's a lot more convenient, diba? You just find one example and then you show that this example, for example, a equals 13, you can find an example for 12, you can find an example for 11. Sobrang appealing nun. Okay, susubukan natin. So, one way to do that is to just do it. Diba? 13, 12, 11. So, what if pwede ka magtanggal ng element from the 13, tanggal ka ng element 12 elements na lang yung A, pero same pa rin yung number of differences. Tapos from 12, tanggal ka ulit na isa, 11, same pa rin yung number of differences. So that would be very, very convenient for us. Yung problem natin, paano natin alam kung ano yung tatanggalin? Paano natin malaman na magtinanggal natin, hindi mababawasan yung differences? So, pinaka-malaking problema yan pagdating natin sa 6. Kasi nga, kung sinubukan nyo maghanap ng example sa 6 kanina, para may specific conditions siya. Hindi lang basta-basta. Tapos, hindi lang tayo basta-basta naghanap ng A equals 6 dito Kailangan A equals 6 na same yung A minus A. So, kailangan yung difference niya, negative 12, negative 11, negative 10, dot, up to 11, 12. So, hindi lang basta size 6 na may specific set of differences. So, napakahirap nun. Hindi ka lang basta-basta pwede magtanggal ng elements, isa-isa. So, that's why we actually start with A equals 6 instead. Kasi, mas madaling magdagdag ng elements. So, nagdagdag ka ng elements. You can actually show na kung nagdagdag ka ng elements from paano ba ito? Yes. So, kung yung set A mo, size 6, tapos yung elements niya between 0 and 12 inclusive, then you can actually show na if you keep putting in elements into that size 6 set, walang madadagdag na difference. Why? Kasi alam natin na yung buong set na 0 to 12, yung A minus A nga is already negative 12 up to 12. So yung size 6 set mo, subset ng 0 to 12, then alam mo yung differences niya is always a subset ng negative 12 to 12. So, nagdagdag ka ng elements within that range, hindi magbabago yung set of differences. Yung problema natin is hindi guaranteed na gagana actually yung method na to. Kasi nga, sobrang daming restriction na natin sa size of A equals 6. So, size of A equals 6, kailangan yung differences niya, negative 12, negative 11 up to 12. Tapos, kailangan yung elements ng size equals 6, 0 to 12 para maging subset siya ng example natin for 13. So, we have 3 conditions. Yung size, subset of 13, the set with 13 elements, tas yung differences has to be size 25. So, ang daming restrictions na nun. Pero here, it turns out na there is actually such a set. So, from this point on, madali na lang siya kasi we have 0, 1, 3, 7, 11, 12. Magdadagdag ka na lang ng elements dyan. So, kung example, dagdag ka ng 2, dagdagin mo yung 4, 5, 6, until na makompleto mo yung set. And there you go. You have examples for 6 to 13. And you only had to prove it for 2 of them. Prove it for 6, prove it for 13. And of course, yung argument we said kanina na the differences are always negative 12 to 12. Okay. So, feel free to pause and ponder over this problem. And let's move on to geometry, which is very different from the other fields. So sa Olympiad, we usually meet 4 na categorizations is algebra, combinatorics, number theory, geometry. So the process for solving geometry is very different from the other problems. So walang small cases sa geometry masyado. Kasi either na-meet mo yung figure or hindi mo na-meet yung figure. So how do we do that? How do we solve a geometry problem instead. So, given this problem, the first step is to actually draw the diagram. So you're not going to get anywhere without drawing the diagram. So, we're trying to find the length AX. Pero, medyo complicated tong diagram natin. Maraming perpendicular. Si point P, medyo alanganin na nga. Hindi na siya related sa triangle. Tapos may point Q pa, lalong hindi na related. Kasi yung point X, parang sobrang wala nang kinalaman sa triangle ABC sa X, diba? Kasi in terms of Q na siya. Si Q in terms of P, parang ang layo na ni X. So how do you deal with this? So playing around in geometry usually means angle chasing. So like this. Oh, balik ko lang camera ko. So it turns out, okay, una muna, bakit angle chasing? So, angle chasing is very, very powerful sa geometry. So, there are a lot of concepts na you can derive from it. You can get similar triangles. You can actually prove a point is unique by showing the same angle. You can do trigonometry on angles. You can actually prove tangency to circles. So, while we're talking about circles, you can also prove concyclic yung points. That means they lie on a circle. 4 points lie on a circle. You can do that with angle chasing. You can also show collinear yung points with angle chasing. So, marami ka magagawa actually sa angle chasing. So that's why that should be your first approach. So here, we have all the marked angles in this diagram are actually of equal measure. So, HCP, PCH, tapos yung vertical angle sa PHC. So, basta yung limang angle na yan, same yung measure. So, feel free to pause the video to convince yourself that that is true. So the hint I can give you is represent that angle with, for example, ano ba, alpha. Represent with alpha, maglagay ka ng 90 minus alpha, alpha sa diagram na to. Hanapin mo yung measures kung saan mo makakayanan. And you should reach the point where indeed you find out na these 5 angles have equal measure. So, di pa dyan tapos yung angle chasing natin kasi meron pa actually ibang set na equal angles. So, itong dalawa. So, we find out na BPQ is actually isosceles. So, that's actually a big deal kasi yung P and Q natin, parang lumulutang lang sila, diba? Hindi sila masyadong related sa ABC. Lalo na si X. Actually, if we go back here, AXQ is an isosceles triangle. Parang big deal rin yun. Parang we know something about X. So, kahit na sobrang layo niya from ABC, at least we know something from X. And here, we know something about P and Q na. So actually, it turns out from our angle chasing, napadali natin yung buhay natin. Kasi we're trying to find AX, diba? Pero, isosceles, so isosceles siya. Medyo madali na natin hanapin si AX from AQ. Maybe we're gonna use some trigonometry, diba? Kasi alam naman natin angle between AX and AQ. And then from AQ, we can find BQ. So, kasi side length 13. So, BQ, we can find BP. That's more trig. Kasi alam natin yung angle na QBP. Then from BP, we can... Sorry. Baliktad pa rin yung pagkasabi ko. We can find AX from AQ. We can find AQ from BQ. We can find BP from BQ using trig. BP from PC and so forth until we reach HC. So HC, medyo malaki na yung kinalaman niya sa triangle. So you can actually maybe, do Cartesian, di ko alam, to find the value of HC. So, parang napakadali na siya at this point. And that's because we chased angles until we found enough properties in this diagram. So if we go back to the original problem, find AX. Para may step-by-step procedure na tayo to find AX. I think na, if I'm not mistaken, when I was starting off sa geom, one of my first instincts would be to Cartesian bash everything. I mean representing everything in Cartesian points. Tapos isolve mo yung coordinates ni P, solve mo yung coordinates ni Q. So if your first instinct for this problem was to do that, don't worry. That's natural when you're not familiar pa with geom masyado. Pero as you get more and more familiar, you acquaint yourself with these techniques para mapadali yung chasing mo. So I tried actually chasing for the points P and Q. Medyo pangit yung lalabas na values. Parang malaking fraction siya. Si AX, syempre malinis. Pero Q, pangit. Okay. So, we have a plan of attack na. So, the process of solving for AX should be straightforward. Pero, there's actually something that simplifies this problem even more. Di ba sinabi ko, we use trigonometry, for example, to get AX from AQ or to get BQ from BP? Well, the trigonometric value is actually very, very clean because your altitude from A is actually 12. So, that's something you can remember for future problems. 13, 20, 21, the altitude from A is 12. So, feel free to convince yourself of this. So, kung mapapansin mo, yung right triangles kasi siya, 13, 12, yung isa, 5, 20, 12, isa, 16. 5 to 16, 21. So, it makes sense. 12 yung altitude. So, with that observation, 12, napakadali na actually yung trigonometry natin. Hindi na siya, hindi ka na makakalikot pa sa mga cosine law. Sa mga complicated na, ganyan-ganyan. Furthermore, the altitude 12 is actually also convenient for, alam ko kasasabi pa lang na wag gawin, pero it's also convenient for Cartesian kasi madali ba nang ma-represent yung A, B, C kasi yung altitude malinis lang na 12. So, for example, A is 0, 12, B is negative 5, 0, C is 16, 0. So, napakadaling Cartesian. Maybe you can use Cartesian to solve for CH, for example. So, medyo out of nowhere yung sinabi kong 13, 20, 21, altitude 12, di ba? Parang hindi naman masyadong tutor sa school yun. Well, you learned that from solving a lot of problems. So, that's why experience is actually very important. So, experience doesn't just refer to memorizing formulas, memorizing configurations, hindi. It's also being familiar with the processes, being acquainted with what you can feel would work for this problem, what you can feel won't work. And in particular, experience gives you a lot of approaches to try. Kasi I know when you're starting off, parang it seems na a lot of problems are not approachable. Parang hindi mo alam saan magsisimula. Well, if you keep solving problems, if you keep looking at solutions, also feel free to read solutions even to problems you've already solved kasi sometimes other people have insightful solutions rin, and maybe you just did some length chasing and you didn't actually feel the problem. So feel free to read other people's solutions rin and learn what they used. So, an example on the importance of experience. So I'm going to say this straight off na if you're beginning pa lang, I don't really expect you to be able to solve this problem, pero feel free to try anyway. So, geometry. First step, draw the figure. And then, yeah, medyo lost tayo kasi how do you even relate ABC to the three circles, diba? Parang radius. Bakit may radius ng ABC? Parang out of nowhere siya. So, here, I'm just going to spoil this part na kasi you need some experience nga to be able to see this. If you actually look at the triangles, the triangle formed by those three circumcenters, O1, O2, O2, O3, O3, O1, you get this. So O1, O2 is the sum of their diameter, their radii, O2, O3, sum of their respective radii. When I look at this, it reminds me of an incircle, because an incircle touches... Yeah, I'll just use the next diagram, which is a spoiler, but makes it this part easier. An incircle touches a triangle at 3 points, so dito ABC. So one property ng incircle is it forms 3 sets of tangent lines that are equal length. So dito, incircle na si ABC. So the tangent from A and from C meet at O1. O1A is equal to O1C. Likewise, O2A is equal to O2B, O3B is equal to O3C. So the incircle has the nice property na it cuts up each side of the original triangle into 2 smaller. Pwede ba magsulat? Hindi ako marunong magsulat dito. Oops. Sorry. But yeah, the tangency points ng circle, ng incircle, it cuts up the sides of the bigger triangle. And it cuts it up in such a way na ito yung lalabas na pattern. Parang one side is R1 plus R2, the next side is R2 plus R3, the third side is R3 plus R1. Medyo related na sila in your head when you think of incircles. So how do you relate that in your head, diba? Parang incircles and this representation. So that comes with experience nga. So personally, I learned that technique for inequalities. I learned that technique because some problems that use the triangle inequality. Some problems that use the triangle inequality have you use this kind of substitution. For example, that A, B, C, B, the sides of the triangle. Then you can actually do A equals C plus V, B equals V plus W, C equals W plus U. You can do that for inequalities. So, medyo tangent, pero that's how I learned this technique. So, this reminded me of an incircle, so I drew the incircle. And you can actually you have to prove na it's really the incircle. So once you've done that, the problem is super easy na. Kasi, yung circumradius ABC, well, it turns out na in radius lang pala siya. Of course, that's not the only way na you can get the insight. There's also, you can look at the radical center of the 3 circles. So if you don't know what radical center is, you can just Google radical axes, radical center. But yeah, the radical center is equidistant to ABC. Tapos the tangents may perpendicular lines ka, so that's enough to prove na incircle siya actually. And yes, once na-prove mo na the circle of ABC is actually the incircle, medyo madali na yung rest, so I'll just leave it to you. Although may hints at the later slides if you need more help. So what was the point now of showing a problem that I didn't expect you to solve? It's to show na there's value in experience, in familiarizing yourself with approaches with configurations, so that in the future, kung may similar configuration na labas, ma-recognize mo. So as a side note, this is also why when you're practicing geometry in particular, when you're practicing geometry, try not to solve it with Cartesian or barycentric agad-agad. I mean, sa contest, feel free to do that kasi 7 points is 7 points. Pero when you're practicing, try to do it what we call synthetically, with similar triangles, with angle chasing. Don't resort to Cartesian or barycentric agad kasi if you solve something with Cartesian, sure you solve the problem pero wala ka naintindihan masyado sa diagram. For example, let's go back to this problem. Like, with the insight na the altitude from A is 12, that's 12, you can actually Cartesian this all the way. Yung problem, wala ka naintindihan sa problem. You get AX, pero hindi mo nakikita yung insight na QPB is isosceles, AXQ is isosceles. Hindi masa-strengthen yung idea sa mind mo na pag perpendicular bisector, pwede ka tumingin sa angles. Parang wala ka natutunan. That's why you should try as much as possible to do geometry synthetically. Kasi it helps you gain experience na you can use on future problems. Okay, so this is the part na I don't want to dwell on kasi short answer isn't really math, it's more of, well, sure, it is math na you can use the approaches I mentioned earlier to solve short answer problems, pero I know na a lot of contestants just cheated. Like, what do you mean by cheated? Here. So, first is, you can just guess your answer. Kasi you get points naman. Like, the judges don't care if you got your answer legitimately or you just magically guessed it out of nowhere. Short answer, you get points for just putting it down. Kaya, an unsure answer is better than no answer sa short answer, so you get the points regardless. So other tips for short answer would be skip items you don't know how to solve. Actually, this also applies for the earlier actually. Even for proving items, you can apply this tip. Skip items you don't know how to solve. For example, kung mahina ka sa geom like me, you can skip a geom problem, try to see if mas approachable yung next problem on the list. Actually, this tip holds very much true for the 25th PMO area stage in general. Magugulat ka na hindi pantay-pantay yung difficulty. Parang patalon-talon siya actually. Like, in my opinion, I think problem, ano ba yan? 14? Is it 14? Basta there are some problems na sobrang hirap which come early in the set. Like, I found problem 14 very hard. And then some of the later problems like 19 is what 19 yeah 19 I found 19 easy. 15 is very easy. Kaya hindi siya pantay-pantay. So feel free to skip items you don't know how to solve kasi limited lang time mo. Tapos sa short answer and be familiar with the mechanics and the quirks of a contest. So may kwento ako dito. So dati sa Mathirang Matibay may mechanics sila sa isang round na the score you get depends is a function of how long it takes you to solve it. So isang kalaban na team namin may naisip silang something brilliant in hindsight. Na-limit nila yung sagot to a set of like 10-20 answers. Tapos, instead of solving it manually, parang sinubmit lang nila lahat isa-isa yung answers. Kasi, so dahil sa mechanics ng round na yon, walang penalties yung wrong answer, walang limit sa number of submissions, basta, function of the time it took you to give the first correct answer. So, ginawa nila, pinam na lang yung answers until makuha nila yung tamang sagot. So, that's not really legit mathematics, pero it does increase your score. So, familiarize yourself with the mechanics. So, back to Olympiad level math. Sa PMO and IMO, USAMO, mga ganon, there are also partial points. So, partial points are, you have to be to be good at getting them ren. Because even if you don't fully get the problem, sometimes just writing down your ideas, proving small observations. Di ba kanina sabi natin, make observations? Well, that's why you do it. Kasi if you prove small observations, or actually, if you prove a big observation, lalo na, you get points pa rin. Actually nga, even if you just write down an observation na walang proof, parang sabihin mo, I claim this is true, sometimes you get points pa rin. So that's why, write down your observations and then submit it pa rin. And last, ano pa, isa pang example for USAMO. This doesn't hold for PMO, but for USAMO, may weirdness rin yung mechanics nila na kung geometry problem, kailangan mag-draw ka ng diagram. Kung wala kang diagram, may -1 point ka. So, sayang naman, di ba? Para na-solve mo yung geometry, pero walang diagram, kaya -1. Yeah, but familiarize yourself with the mechanics ng contest. So, last tip for short answer is make reasonable simplifying assumptions. I'm sure you're familiar with this. So, for example, kung sabi ng problem, if all the medians are of length 5, then assume mo an equilateral. Because, sure, it doesn't really help you learn about the problem, pero it helps you get at the answer faster, which is what's more important sa short answer, which is time management. Kasi wala naman proof eh. So, that's why I don't really recommend training for short answer if you're going for an Olympiad style contest, kasi short answer doesn't really hone in your proving skills. But anyway, let's just demonstrate what I mean. Problem 20 ng area stage this year. Determine the sum of all positive integers n for which 2 times the number of divisors of n squared is equal to 3n. So, one of the instructions you need to be familiar with for the area stages, for part 1, which is, this is problem 20 of part 1, all the answers are between 1 and 999. So, that's already, well, kung gusto mo, you can try out 999 possibilities. Walang mahihinto sa'yo, except in time limit. Pero yeah. From the get-go, just from the mechanics, you already know something of the problem, even though wala ka pang insight. But still, we're going to find some insights anyway, kasi insights can help you simplify a problem. So, just move 2 to the other side. 3/2 n is a perfect square. So, 3/2 n is a perfect square. That means n is of the form 6m squared. So, since the answer is at most 999, we only need to check m equals 1 to up to 12. So, that's already a big improvement. You don't need to check 999 possible n. You can only check 12 possible m na, which is a lot easier and doable within the time limit. Although, we can actually still do better. So, remember what I said earlier na about changing perspectives, like, one of that would be reinterpreting what a quantity means. So, let's just substitute n equals 6m squared para mapadali. So, what does it mean for the number of divisors to be even, number of divisors to be odd? So, I think medyo well known na if the number of divisors is odd, it's a perfect square. But actually, that follows from the formula. If you don't know the formula for the number of divisors, you can look it up. If the number of divisors is odd, it's a perfect square. If it's not odd, it's not a perfect square. What's 6m squared? 6m squared is not a perfect square. Kaya, the number of divisors of 6m squared is even. So 3m is even. So m is even. We can actually write n as 24p squared. So, ngayon, 6 cases na lang tayo. So, lalong madali yan. That's very, very much doable na. So, okay, so that's it na for my tips on problem solving and a short section on short answers. So, the problems are available online, and the answer key and the solutions to part 2 are also available on the official PMO Facebook page. Pero wala atang hints for part 1, kaya I'm just going to add hints for part 1 here just in case na you need them. So a few of these problems are actually really easy. You should try, ano ba? Madali. Problem 12, madali siya. Problem 6, wala na ako hint nilagay. So I think 6 should be doable. So yeah, just go through the problems and look at these hints if you need to. So I think that's it. Ay, hindi. Nga pala. So where can you get more problems to practice solving? You can look it up online. For example, aops.com has a lot of math problems. Parang may archive rin sila ng mga Olympiads from different countries, like IMO, APMO, tapos yung USA MO, yung Korean MO, Japan MO. So maraming problems sa aops.com. You can try to get experience from that. Although for if you're still beginning pa lang, you can try the junior contests first, junior Balkans. Try the first problems. First problems are generally easier than the later problems. And yeah, so for short answer naman, you can, for short answer, I'm sure na the math department is still training, math unit is still training you on on oral type problems. Parang dati kasi nalala ko pa yun. So I'm sure short answer you should get a lot of practice on short answer. But if you still need more practice on that, you can look up for AMC, like American and the Australian version, also on aops.com. So yes, so that's pretty much it. So thank you for listening to this pre-recorded talk. So balik ko lang sa tips ko. So if you need something to return to, just return to this list, just so you have an idea of what to do when you face an Olympiad style problem. So thank you very much for listening.